Hello friends. Okay, in this lecture we will see the partially miscible liquids. Okay. Now what is meant by partially miscible liquids or partially miscible liquid pairs? We will consider only binary solution. What is partially miscible liquid pairs? Means the pair, suppose we consider two liquids A and B. This is called partially miscible liquid pair only if they are miscible or divisible in one another to limited extent or limited amount. If we consider pure A, suppose we consider 100 ml of pure A. If we add a drop of B, it will be miscible. If we add one more drop of B, it will be miscible, and we go on adding drops, and after certain time two layers are separated. Two different layers will be formed. Means after that B is not miscible with A. Similarly, if we consider pure A, and if we go on adding pure B, two layers will be formed. Vice versa, if we take B and we go on adding A, after some time two layers are formed. Such solutions are called partially miscible liquid pairs. Liquid pairs which are partially miscible or dissolve with one another to a limited extent. Okay, on the basis of its mutual miscibility. Mutual miscibility means miscibility of A with B as well as B with A. On the basis of mutual miscibility, there are three types of partially miscible liquid pairs. Which are these three pairs? The one pair, the pair whose mutual solubility, mutual means solubility of A in B as well as B in A, goes on increasing with increase in temperature. The solution, first type of solution is the solution whose mutual solubility goes on increasing with increasing temperature. It is also called as a maximum solution temperature type. It is also called as a critical solution temperature type, CST, maximum CST. Okay. Critical or may be called as a consolidate temperature. Okay, first type is the solution whose mutual solubility increases on increasing temperature. Second type of solution is the solution whose mutual solubility decreases on increasing temperature. If we increase temperature, mutual solubility decreases. Such solutions are called as a minimum solution temperature type or minimum CST, lower CST. Okay, and third type, the solution whose or pairs whose mutual solubility increases as well as decreases. Both happens. Initially increases, then decreases on increasing temperature. Means it is also called as a maximum and minimum solution temperature type. Depending on the mutual solubility, there are three types of solution. First type is the solution or pair whose mutual solubility goes on increasing with increasing temperature. Second type is the pair whose mutual solubility decreases on increasing temperature. And third type is the liquid pairs whose mutual solubility increases as well as decreases on increasing temperature. Okay, let us consider one by one. We will see first of all maximum solution temperature type. Maximum solution temperature type, also called as upper CST. We will see what is CST and upper CST. Now, the best example of this pair, first type of liquid pairs, means the solution whose mutual solubility or mixture or pair whose mutual solubility goes on increasing temperature. Best example is Phenol-Water system. Phenol-Water system. Now, phenol and water, both this phenol as well as water, are partially miscible with each other at given temperature. At ordinary temperature, suppose room temperature, phenol and water are partially miscible with each other. Means, if we consider a small amount of phenol is added, in large amount of water. Suppose if we add 1-2 drops of phenol in 100 ml of water, it is completely miscible. But on adding phenol, more and more quantity of phenol, 2 layers will be separated. Yes. Similarly, if we consider 100 ml of phenol, and if we add few drops of water, it is miscible, completely miscible. But after some time, if we go on adding more and more amount of water, 2 layers will be separated. That's why they are partially miscible liquid pairs. Okay. Now, if we take certain amount of phenol and water, suppose 30 ml of phenol and 50 ml of water, whatever may be, any mixture, and if we shake it, there is a formation of 2 layers. One layer is the solution of phenol in water, other layer is a solution of water in phenol. Got it? Yes. 2 different solutions of 2 different composition. This solution has a different composition. This solution has a different composition. One is a phenol in water, other is a water in phenol. Such solutions of different composition exist simultaneously. Thus, they are called as conjugate solution. They are called as conjugate solutions. Means 2 different solutions of 2 different composition coexist with each other simultaneously, called as a conjugate solution. And as we go on increasing temperature, okay, here one solution is a phenol in water, other solution is a water in phenol. You know well what is phenol in water and what is water in phenol. Yes, water in phenol means water is a solute, phenol is a solvent. And Phenol in water means phenol is a solute and water is a solvent. Okay. One solution is a phenol in water, other solution is a water in phenol. Okay. Now, if we consider a mixture of two solutions, a mixture of phenol and water, certain amount of phenol and water is taken and the mixture is shaken well. Now, one layer is a phenol in water, other layer is a water in phenol. Okay, such simultaneous happens, that's why called as a conjugate solution. As temperature increases, if we increase the temperature of this solution, as temperature increases, concentration of phenol in water, this is a solution of phenol in water. This is a solution of water in phenol at room temperature. Suppose if we increase temperature, concentration of phenol here increases, as well as here concentration of water increases. Means as temperature increases, the concentration of phenol in water as well as water in phenol goes on increasing. And ultimately, after certain temperature, two conjugate solution changes into a homogeneous solution. And this temperature is called as a consolidate temperature or critical solution temperature. Yes, got it? Since it is at upper limit called as a upper CST. What is meant by upper CST? It is the temperature above which two partially miscible liquid pair becomes completely miscible. And in case of phenol water system, it is 66.5 degrees Celsius. Okay. If we plot the graph of solubility and temperature, the graph is as like this. Yes. Here. What is here? We have taken a pure water. Here pure water is present. There is only one layer. As we go on, initially if we add along this 100% water means along this direction phenol is added, and along this direction water is added, or water composition increases. Along this water composition decreases. Okay. Now here we have 100% of water, and as we go on adding phenol, initially what happens? Water, we are taking water. As we go on adding phenol at certain amount, here there is no formation of two layers. After certain temperature, two layers are formed. After certain amount of phenol is added, two layers are formed. But if we increase temperature, it becomes miscible. Yes. Now, if we consider at any temperature, suppose T Kelvin, at any temperature, composition of each layer is fixed. If we consider a temperature, at this temperature, composition of two layers is fixed, and it is indicated, composition of it is indicated by A. At this temperature, whatever may be the amount of substance, this is the composition of water in phenol, phenol in water, and this is the composition of water in phenol. Here we have 100% water, means this gives the composition of phenol in water, this gives the composition of water in phenol. Means the point A gives the composition of water in phenol, and this gives the composition of phenol in water. This is the water layer, this is the phenol layer. Okay. Okay. Now, if we consider any point in the circle, if we consider any point, suppose x in the circle, it consists of two layers. Conjugate solution, any point here also. It consists of, if we consider a composition this, it consists of two layers. One layer is the phenol in water and other layer is a water in phenol. Yes, and the composition is this at this temperature. If we increase temperature, at this temperature what happens? If we consider this point, this composition, what happens? If we consider the composition of water and phenol this, then what happens? At this point, suppose y, the composition of phenol in water is this A, and composition of water in phenol is this. Yes, and as we go on increasing this, we will get a parabolic curve, this ACB, parabolic curve. Outside that curve, there is only one layer. What is this? Suppose we consider this P, point P. This is the unsaturated solution of phenol in water. Okay, water is more. This is the unsaturated solution of phenol in water. And this point, suppose Q, point Q represents unsaturated solution of water in phenol. Any point above this temperature, suppose Z or here W or here say K, all these points are again unsaturated solutions of water in phenol or phenol in water, whatever may be. Because above this temperature, these two partially miscible liquids becomes completely miscibles. That's why it is the critical solution temperature. And at this critical solution temperature, this is the composition. Means at CST, upper CST, what is the composition? Yes, it consists of 36.1% of phenol in water. Okay, but this is more important. CST, upper CST, it is 66.5 degrees Celsius. Got it? What is upper CST and what happens in case of phenol water system? If we consider any upper point, this, it is unsaturated solution. If we decrease temperature, temperature goes on decreasing. No doubt, temperature goes on decreasing. Just a minute. If we consider any point above this critical solution temperature, suppose say Y. If we decrease temperature, temperature goes on decreasing, no doubt. But at this temperature, say T1, two layers are separated. Yes, two layers will be separated. Then it is the solution of saturated solution. Exactly at this point, it is the saturated solution of phenol in water. Why? Water is percentage here, more percent. If we take to this side, it is the unsaturated solution of phenol in unsaturated solution of water in phenol. On decreasing temperature, temperature goes on decreasing, just temperature decreases. But at this point, it is the saturated solution. And if we decrease temperature, what happens? Composition goes on changing. Composition goes on. What is the composition of this solution? One solution is the One solution is the solution of water in phenol, other solution is a solution of phenol in water. Composition of any solution inside the parabola is given on this curve, by this curve, points on this curve. Outside there is only one layer. Outside there is only one layer. It is the unsaturated solution. Along this curve only there is a saturated solution. Exactly on this curve. Here it is a saturated solution of phenol in water. And this is the saturated solution of water in phenol. And inside, no doubt it is a saturated solution, but we call it as a two solutions coexist with each other, we call it as a conjugate solutions. Got it? Okay. There are more liquid pairs also showing such phenomenons like aniline and hexane. Aniline and hexane. N-hexane. These two liquids also shows same phenomenon. Or methyl alcohol, methanol and CS2. This pair also, carbon disulfide, this pair also shows such phenomenon as like phenol-water system, where there is a upper CST. Here upper CST is different for a different system, but it is a particular or it is a characteristic of that system. In case of phenol-water system, it is exactly 66.5 degrees Celsius. In case of aniline and hexane, the value is different. Yes, it is 332.6 Kelvin, slightly less. Okay, got it? Okay, thank you. Remaining two types we will see in next lecture. Okay, bye.